All right, real quick. I'm not asking you to do it all. I just want to hear your thoughts. If I asked you for the distance between A and B, how many of you would be pretty comfortable finding that distance between A and B using the distance formula? Would be pretty comfortable, right? Okay, today and tomorrow I'm going to get you out of your comfort zone. Because instead of negative 6, 4, the coordinate now will be negative 6A, 4B. And instead of negative 2, 1, it'll be negative 2A, B. And I'll ask you to find the distance between those points now. So you're going to be taking variables and plugging them into the distance and midpoint formula. Okay, that's what we're going to go over the next today and tomorrow. So take a look at example 1 here. Let's get right into the variable coordinates. I am asking you guys to place right triangle ABC somewhere on your XY axis. But there's conditions to it. I just can't put, oh, here you go. Here's your right triangle. Next problem. Right? It's got to serve certain conditions. And here are the conditions. Every right triangle has 2 legs. It's the 2 that are not the hypotenuse. Those 2 legs, one of them I'm going to call AC, and it's got to be a length of 2A. 2A. The other leg you're going to call AB, and it's got to have a length of 2B. Not a length of 3, not a length of 4, a length of 2A and 2B. So what I'm going to do with you first, before I put it on an actual graph, I just want to sketch what's going to happen here. You don't have to. I just want to sketch a look at, okay, here's where A is going to be, B, C, 2A, 2B. Okay, that's right there. All right, we're good. What vertice do I have to have at the right angle? Have to. The legs are AC and AB. It's got to be A. So I'm going to have A here at the right angle. B and C, does it really matter? No, because both will be legs. So it doesn't really matter where I put B and C. All right. How long does AC have to be? 2A. So when I put this on a graph, I need to put the proper coordinates of A and C. So when I put them together, this length will be 2A. How long does AB have to be? 2B. So I'm going to have to put proper coordinates at A and B. So this length here is going to be 2B. All right. So let's try to move this onto the graph with coordinates for A, B, and C. Now I'm just not going to say go do it. I'm going to give you guys some couple tips. First tip, huge tip. Step 1, try to use the origin. Try to use the origin as one of your points. All right. What point do you think I should and see? Let's be probably point A. Yep. So let's make point A 0, 0. Come on. Okay, here we go. Point A. Those are the only numbers I'm allowed to use, 0, 0. The other everything else should be with variables. So always try to put a vertice at the origin. Make life easy. Second tip for you. Try to put one of the sides or both sides on the axes. Okay, on the axes. Where do you think I should put point C? Somewhere where? Yeah, darn right. Put it on the x-axis. All right, now here's where we start getting serious because what's got to be the distance between A and C? 2A. So I need to come up with the correct coordinates so the distance will be 2A. Well, you guys told me to put it on the x-axis. So what coordinate is always 0 on the x-axis? No matter where I put it, a point on the x-axis, what coordinate is always 0? What about your x-coordinate here now? Remember, it's got to be how long? It's got to be a length of 2A. So what's my only option to put in for x? 2A. Yep. Now this is from 0 to 2A. Perfect. Suggestions on where I should put B? Y-axis. Yeah. Why not? That's going to form a right angle. All right, let's talk because it's got to be a specific coordinate. What are all the x coordinates on the y-axis? So it's got to be 0. And how far up on the y-axis does it have to go? 2B. And there it is. There's the right triangle they asked me for. Now, is this the only place I could have put it? No, ready? If you're really feeling crazy today, I could have taken point C, flipped it over here, and made it what? Negative 2a, 0. If you're feeling really nuts, take B, flip it over, and make it what? 0, negative 2b. Okay, so multiple spots you could have put this triangle. But is everyone all right on the right triangle? That's usually the easiest, the way we started off. Placing a right triangle somewhere. Everybody good? Okay, we got a right triangle. Let's move it to isosceles now. Yep, here we go. That stings. That stings, yeah. All right, here we go. Curtain and star, always a go. You can always be a little confident in that, but hey, you want to do cube? You do cube, sure, because we've seen cube all the time. Yep. All right, moving on. All right, now we go to isosceles, which is a little bit tougher to graph with the variables. I use a vocabulary term right off the bat. I got isosceles triangle FGH, base FG. Base does not equal bottom. Get out of the middle school. Base does not equal bottom. What did we say was the base of an isosceles triangle? Not the bottom. I don't want to hear that. It's the non-congruent side. Yes, so the non-congruent side will be 2a units long. Okay, the non-congruent side will be 2a units long. So really, we're looking at something like this. If I put FG here, that's got to be 2a, h up top. That's what I'm looking at here on the graph. All right, on the graph. And I need coordinates for F, G, and H. All right, suggestions. Where should I start this graph? Origin with point F, 0, 0. Yep. Where should another point go, and what should it be? G, where should I put G? Somewhere on the x-axis, right? Somewhere on the x-axis. And you know FG's got to be 2a units long, so what's my coordinate of G? 2a, comma what? 0. All right, now we get a little nuts. Because you know H has got to be in between F and G, but it's got to be a certain coordinate because it's what type of triangle? Isosceles. So you can't just name it X comma Y. All right, that's not going to be isosceles. All right. If it's going to be isosceles and this is the base, that means these are the legs and those are equal to each other. So where does H have to be positioned as far as F and G go? Right in the middle. Right in the middle. I got 0 and I got 2a. What's in the middle? A. Well, it can't be 0. Why can I not put 0 there? It's not on the y-axis. All right, so let's talk. What about that y coordinate? Okay, what about it? Well, let me ask you guys first. Let's say I don't put H there. Don't do this. Let's say I put H right here. Is it still isosceles? Yeah, it's still isosceles. What if I put H way up here? Still isosceles? Even as long as it's got x coordinate of A, that's fine. Can I put it right here? Okay, what am I trying to get across to you guys about the y coordinate? Does not matter. You can put whatever, don't put a number there. All right, you can put B, C, X, Y, happy face. Don't put that, but all right, anything you want. 2B, 2H, whatever you're feeling. All right, what are we feeling here? A, comma, C, fine, you can have A, comma, C. You can put whatever you want, go ahead. Put whatever variable you want. It's still going to be isosceles no matter where it is. All right. And I know you guys always appreciate this question. What class are we in? Yeah, so because we're in honors, we're going to do this a second time. And this time, you're not allowed to put a vertice at the origin. Yeah, here you go. That's going to be point F. That's going to be point G. You're just doing this. I don't have room. If you have room next to it. And on the y-axis is going to be point H. You and your group are going to discuss what's the coordinates have to be now. Same rules. It's still got to be isosceles. FG still has to be 2A units long. You guys discuss in your group these new coordinates. Okay? Now that you can't start at the origin. I'll give you about 2 minutes. Discuss what are my new points. Same conditions. All set? Let's hear from the group with, good job, 26. Good group over here. 17. Yep. One person answer, point F. Negative A, 0. Somebody else, point G. Okay, good. Why is this going to work? How long did FG have to be? 2A, ready? How long is it from F to the origin? 1A, and then from the origin to G? Hey, I heard some people say negative 2A, 2A. That's 4A. All right, that's 4A. Can't have that. And then somebody else, what about your coordinate from H? 0R, fine. Could be 0 anything. All right. Okay, any questions? All right, now all I'm going to do, I just want you to work on A and B right now in your group. Find the missing coordinates. And make sure, again, you communicate with each other, because if your number comes up, your group is up. A and B only. Do not go on to part C. A and B only. We'll first start with part A, isosceles triangle XYZ. Group with 21. Here we go. Somebody from that group, point X. I know I started you off with a tough one. 0, 0. How about point Z? A, 0. And now point Y does matter, the X coordinate anyway. Who's got point Y? Okay. Anything you wanted. You could have also had A over 2. If anybody had A over 2 as the X coordinate, perfect. Okay, and then the Y coordinate could have been anything. All right, B was a little trickier because you did have to pay attention to the Y coordinate. All right, for point A. Just couldn't make it anything you want. Can I get the group with 26? Yeah, you do. 13, here you go, that group. I'll start you off easy. Point B. 0, 0. There's a tough one. All right, point C, another one. A, 0. Now here's why point A mattered. Because these two have to be congruent, and I already knew how long was BC here, this bottom leg. How long is BC in that diagram? A units, so this also had to be A units. So your Y coordinate couldn't have been anything you wanted. All right, so going back to that group, what's my point A coordinate? Had to have been 0A. You can't have 0B, 0C, 0 your favorite letter there. It had to be A. It had to have been A. Everyone see why? Because if you call this 0B, now this has a length of B and it's not isosceles anymore. Questions before we get to the big dog? I'm ending this with a bang today. Focus in, let's roll. Now what type of triangle am I dealing with? Equilateral. All right, here we go. New rules here. W, I know that's a tough one. Let's get it out of the way. 0, 0. Let's go to point Z. How about the X coordinate of point Z? It's got to be A, halfway in between. That still applies. Okay, but now the Y coordinate does matter. This is not isosceles. Here's why. It's not isosceles anymore. So watch. If I put point Z right here, is that isosceles anymore? No, definitely not. I mean, excuse me, equilateral. Is it equilateral anymore? Absolutely not. All right, so the Y coordinate has to be specific. to make it equilateral. And it is going to be a tough one. All right? It's just not something you can make up in your head either. Okay? So here's what I'm going to have you do. We are going to draw a perpendicular line straight down from Z. And I'll show you why that's going to help. Okay. Does everybody agree whatever the length of this line we just drew in will be my y-coordinate, because that's how far it goes up on the y-axis. So if you can find me the length of this segment, that will also be that y-coordinate I'm missing. We're all in agreement there. Okay, so I am going to try to find that length. I'm going to call it x. All right, I need to find out how long that line is. Once I do, that'll be my y-coordinate of z. Do you see the right triangle you formed on the left side or the right side? Can you guys help me find the other two side lengths? Because I'm trying to find x, one leg. What's this leg here? How long is this leg here? A, yeah, halfway. So that's going to have a length of a. And how about the old hypotenuse here? Remember, it's equilateral. How long was this distance here from W to Y? 2a. That means any side's going to be 2a because it's equilateral. So does everybody see the right triangle right now we have built? X I'm trying to find. This side's A. The hypotenuse is 2a. It's going to be uncomfortable because usually I like working with numbers. And well, it's not numbers anymore. Any device we can use that we've used in the past? Pythagorean theorem in a right triangle, right? All right, so I know Pythag, a squared plus b squared equals c squared. All right, one group is in for it here. Uh-oh. 14. What group are we working with here? Whew. All right, here we go. One person give me a leg to plug in. X squared. Plus somebody new, give me the other leg. There's only two legs up there. X squared's already done. A squared. Equals, what's my hypotenuse squared? Somebody new. Okay. Wrong. Not you guys, me. Anybody want to tell me, anybody see the why I'm mathematically incorrect here? When I write 2a squared, what's being squared? Just the way I wrote it, just the a. But what do I need to square? The hypotenuse. So is everyone all right? Trying to solve for this line segment because that's my y-coordinate. I'm doing Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. All right, here we go, crew. Not off the hook yet. Algebra skills going in. What are we solving for first? No, what are we solving for at the end here? I need x equals at the end. So make sure we're all clear. I need x equals. So let's clean this up. X squared plus a squared. What is 2a all squared? 2a times itself. 4a squared. Remember, I'm solving for a squared. Next move, group. You're trying to get x squared by itself, right? So move the a squared over. How? And this, my anxiety, blood pressure, everything went through the roof. Last period. What do you get on the left side? This, I couldn't believe this was said out of people's mouths in an honors class. 4a squared minus a squared. Please don't say anything. Just think about what it should be. There are algebra teachers at the middle school crying a river of tears for you guys that in your head think this is equal to 4. Because you pulled this business. Whoa. Whoa. Come on now. 4a squared. 4a squared minus a squared. Group. Yeah, 3a squared. Whoo, buddy. All right, let's keep trucking. What's your next move? Square root of both sides. All right, now let's tackle what's inside there. Okay, can you take the square root of 3? No. Can you take the square root of a squared? What is the square root of a squared? A. So I have a on the outside because I took the square root of a squared. What's still left underneath the radical? There's your y coordinate. It's got to be for it to be equilateral. Told you it couldn't be anything you wanted. Again, all right, again. This distance right here is a radical 3. That's how far up it goes on the y-axis. So there is my y coordinate, and I do it using Pythagorean theorem. Yes, it feels uncomfortable because it's brand new and the algebra is kind of tough. All right, yep. Okay, here's basically what I did. Good question. I took this right here, and I just did this. I broke it up into 2. Right? I said I can't take the square root of 3, but I can take the square root of a squared. What's the square root of a squared? Okay? So you look underneath, can I take the square root of anything there? Okay? Questions? Yes, go ahead, Cece. That's the same as 2a times itself. Right? 2 times 2 gives me 4. A times a gives me a squared. Good? Anything else? Good questions here. Good algebra questions. Okay, you guys more than likely are going to almost complete this homework if you get going and don't waste your time yapping about everything outside of class.